The earliest tires were bands of steel fitted to wooden wheels, hardly a comfortable ride. Air-filled inner tubes were part of the first successful car tire in 1911, and inner tubes are still used today in most bicycle tires and many motorcycle tires. These motorcycle inner tubes are made with a combination of synthetic and pure natural rubber. They come in a variety of sizes and offer superior quality because no recycled or reclaimed rubber is used during the manufacturing process. A worker selects a slab of synthetic rubber, a bag of carbon black, a package of chemically enhanced rubber, chemicals used as antioxidants, accelerators and curing agents, and finally, a package of pure natural rubber. A worker pulls the materials from an internal mixer and guides them into a two-roll mill, where they're squeezed together. He trims off the rubber sheet. Ideally, the texture of the rubber sheet is smooth. Carbon black provides pigmentation to the process and reinforces the rubber. The rubber is now sent for cooling. It soaks in a mixture of calcium carbonate, which, once dry, will prevent the rubber from sticking to itself. Workers carefully fold the continuous sheet of rubber in a stack to dry. The next day, the rubber is cool and hard, and the calcium carbonate has dried into a powder. A worker places the small strip coming out of the two-roll mill onto an overhead conveyor belt, which takes it to the next phase of production. The strip falls into an extruding machine, where a turning screw forces the raw rubber through a strainer. A worker uses a wire to cut the rubber strands as they emerge. He places the rubber wad in the two-roll mill once again. The rubber will gradually be shaped in preparation for the next phase of extrusion. Squeezed into a strip, the rubber falls into a tube extruder machine. As it passes through the die, it emerges in a cylindrical shape. The rubber tube is hot. Water cools it down and cleans away any remaining residue. The rubber tube now enters a cutting machine. Calcium carbonate powder helps prevent sticking. After being cut, a hole is punched in the tube and a valve inserted. The first cone punches the hole. The second inserts the valve. A worker replaces each valve after it's been inserted into the rubber tube. This machine can process 22 tubes per minute. Here's the rubber tube with the hole punched and with the incomplete valve inserted. A worker now connects the two ends of the cut tube. He places both ends into the machine, which, using different steps, cuts and fuses them together. By the time the machine completes the process, the worker has two more loose ends in place. First, the knife cuts both ends of the tube. By clearing away the calcium carbonate powder, the two heated ends can stick together. No glue is needed. The cut is clean and straight. Heat, combined with the rubber's natural stickiness, firmly holds the seam together. A worker now pumps air into the circular tube. He hammers wax into the incomplete valve in order to temporarily seal the air inside. Another worker places the tube in a mold. It will be heated for a few minutes, part of the vulcanization process. The wax that held the air inside has melted, but after being vulcanized in the mold, the tube retains its cylindrical shape. To flatten the shaped tube, any air remaining inside is removed using a vacuum. These workers give the inner tube its finishing touches. They complete the valve by adding a core, followed by a ring, a nut, and a valve cap. They fold the finished inner tube and circle it with two elastic bands. The folded inner tubes are inserted in packaging that is then heat sealed. Ready to hit the open road, these motorcycle inner tubes are sure to get riders pumped.